Okay, let's take a look at the third question, or question number 17 in Chem 11 sample exam 1. This one gives you the following information. It says these compounds called polyfluorinated biphenyls has only 3 elements in it, carbon, hydrogen, chlorine. Chemical analysis shows that the PCB has a molar mass of 360.88 grams per mole. And then combustion of 1.52 grams of the PCB produce 2.224 grams of CO2, and then combustion of a different sample, 2.53 grams, now produce 0.2530 H2O. This is a combustion analysis question, except that they're kind of giving you two different data set. Usually combustion analysis, they just give you combustion of one compound and they give you both the CO2 and the H2O in one combustion. But in this case, two different combustions are done, and so one combustion gives you the CO2 and then the other combustion gives you the H2O. So you can't just directly calculate the mass of the carbon or the hydrogen like we did in class, but what we have to figure out first is the percent composition of each of those elements. So we need to figure out what is the percent carbon, what's the percent hydrogen, and what's the percent chlorine. Then once we have those, then we can assume 100 grams of compound and then use them to figure out our empirical formula. To get the percent carbon, remember that all the carbon in CO2 comes from your PCB. So mass of carbon in PCB is going to be calculated by taking the mass percent of carbon in CO2, 12 grams per mole, and then CO2 is 44. That multiplied by the 2.224 gives you the mass of the carbon in CO2, which is 0.6065 grams. But remember that since all the carbons come from the PCB, that's also the mass of carbon in the PCB. That's the mass of carbon you have in 1.52 grams of PCB. But since the H2O information comes from another sample of PCB, we can't just say that that's the mass that we're going to use for our empirical formula calculation. So we need to convert that to percentage first. So we'll say percent carbon then in PCB would be equal to 0.60654 grams over the mass of the PCB, which is 1.52 grams. And so if we do that, we get 39.9%. And then you do the same calculation for hydrogen. So all hydrogen in water comes also from PCB. That's another assumption we make in these combustion analysis. So what's the mass of hydrogen in the PCB then? It's going to be 2 over 18. 18 is water. And then multiply that by the mass of the water that you have here, which is 0.2530 grams. You get 0.02811 grams. Since all the H comes from PCB, that's also the mass of H in PCB. Like earlier, you can't just use that number directly to calculate number of moles because it comes from a different sample of PCB, not the same one like the one that produces the CO2. So we're going to have to calculate the percentage instead. So percent of H in the PCB is then going to be 0.02811 grams of the H out of the PCB, which is 2.53 grams. Then multiply that by 100%. So that's the actual percentage of hydrogen in this PCB. Then the third number you need, of course, is the percent of the chlorine. So you're going to take 100% because 3 should add up to that, minus 39.9, minus 1.11, and 59% chlorine. What you just did is solve question number 1, kind of figure out the percentages of all of these elements. To figure out the empirical formula, we need to convert all of these numbers to mole ratios of the elements. So we can start by assuming 100 grams of our compound or of our PCB. That means there is 39.9 grams of carbon, 1.11 grams of hydrogen, 58.99 grams of chlorine, and then we gotta go and figure out the mole ratio. Okay, so number of moles of carbon, 39.9 grams over 12. Hydrogen's 1.11 divided by 1. And then chlorine, 58.99. In this case, the chlorine is 35 grams per mole. Okay, carbon is going to be 3.325. Hydrogen is going to be 1.11. Chlorine will be about 1.66 moles of chlorine. From there, reduce them to whole number ratio. So you're going to divide all of them by the smallest number, which is 1.11 in this case. This would be about 1.5 chlorine moles. This is 1 hydrogen and 3 moles of carbon. Relationship is then 3 carbon to 1 hydrogen to 1.5 chlorine. Multiply across here by 2 to get rid of that half. So you got 6 carbon, 2 hydrogen, and 3 chlorine. Your PCB is going to be C6H2Cl3. If you go back to the question, they say, how many chlorine atoms does the PCB molecule contain? Okay, so now it's asking you for the actual molecule. Now, one of the things that we were given earlier in terms of information is the molar mass of the actual PCB, which is 360.88. So this is the empirical formula. So to get the molecular formula, we're going to multiply this by some number n. Remember, some whole numbers. So to get that n, we would take the molar mass, right, which is 360.88. Then we would divide that by the empirical formula mass of the PCB, 180.5 grams per mole. So that means that your N is 2, so the actual molecular formula is going to be C12H4Cl6 because your N is 2 in this case. So then going back to the actual question, it says how many chlorine atoms does this PCB molecule contain? So really what they're asking is in one molecule of PCB, how many chlorine does it have? So it has 6 chlorine in this case. So 6 chlorine atoms is the answer there to the last one.